Okay, good morning. I'm Jeff Murray from AVPROCONNECT and Meridio, and today we're going to have about a 40-45 minute presentation on how to distribute 4K 60, 444, and high dynamic range, which is more important than even the 4K 60 piece of it. So why are we having this today? It is very, very current information on how to get HDR distributed to multi-room dwelling, mainly in high-end residential. These devices are in the field now and coming out and improving daily. Streamers, UHD players, game stations, these are all requiring to get the best possible picture on screen. They're requiring signals, HDMI signals that are above 10.2 gigabit, and that's why we kind of need to learn about what that all means. So high dynamic range and wide color gamut, mostly high dynamic range is probably the most significant event that's happened in video in a long time. And I mean going back even to the days of switching over from composite to component and then component to HDMI, not so much of a change, but HDR is a major change. And what's happened is technology has caught up with what we've been seeking for years and years and years. It's just things have just gotten so much better and better on the display side, so now we have a way to reproduce content that we were not able to reproduce even as little as 2 years ago, unless we went into a studio monitor and if we're talking $30, $40, $50,000 for a display capable of reproducing this type of an image is now available to consumers for as low as what I saw last week in a TCL for like less than $500. All right, so what do we need to know? This chart, we call it our line of innovation. The line of innovation chart covers the bandwidth, and the bandwidth is something new to us because with 1080p category extenders, HDBaseT, previous to that there were some that you had to EQ based on the cable length. That didn't require much more than about 5 gigabits per second. At the very high end, 5.91. Now we've got signals down here. Oops, let me go back up. Down at the bottom of this page that are requiring almost 18 gig. 18 gig is the full spec for HDMI 2.0. And if you look at that, the menu screens on these new UHD discs, they are all running at about 18 gig. 4K 60, 444, 8-bit with HDR and wide color gamut. Most of your Blu-rays are outputting 4K 24 frames, 444, your chroma subsampling. 444 is full, that's like RGB, 12-bit, HDR, and wide color gamut. Where there's some misconception in the field, there is this format up here, actually right here, 8.91, so it's under HDBaseT capability, so it's possible. 4K 24, 420, 10-bit with HDR and wide color gamut. Unfortunately, televisions can't reproduce that signal. That is the native resolution for the new UHD disc with HDR. That's native. Native meaning what's burned onto the disc. When it comes out of the player, it comes out 4K 24, 444, 12-bit. So keep that in mind. That's where there's a lot of confusion in the field right now because people are starting to say, oh, well, native is this. Why don't we output it in native? Well, that's just not the way it's being done. This is exactly the way it's being done right on this screen. So keep that in mind. You need distribution products that can exceed the capability of a traditional HDBaseT extender. All right, so what do I mean this has been known for a long time? ISF, Imaging Science Foundation, has had this in their documentation for probably 15 or 20 years that I know of. but these are the 4 factors that most influence video quality. And number 1 is dynamic range. If you think about it, we've had, and by the way, I should have said this at the beginning. You can ask questions throughout this presentation in our chat box. We have a person monitoring the chat box. He'll answer those as they come up, and then we'll also answer questions at the very end. But anyway, so number 1 is dynamic range. Number 2 is more color. Number 3 is better color. And then number 4 is resolution. And that's why, you know, we've had 4K displays since 2013, but it wasn't really until last year that we had major adoption with the inclusion of high dynamic range from the folks at Dolby, and now there's a generic SMPTE version of it that we'll talk about here in a few slides. So what does dynamic range do? This is probably the simplest way to explain it. It is a 3D model in 2D. The third dimension, you know, being luminance. But if you look at the capture side of this, this is the original scene dynamic range. So this is how it's captured off the camera in Hollywood. You know, you got color information, contrast information, fully uncompressed. It's been captured like that for years before we were able to reproduce it. In today's systems, which are called SDR or standard dynamic range, which everybody's been watching forever and ever, and we probably didn't know we could get anything better until people saw HDR, but that really compresses down the amount of information that gets sent to the television. So the amount that gets sent to the television it's good, but it kind of tops out at about 100 nits. Nits are a measure of light that the eye sees. So light output is like ANSI lumens when you look at a projector spec, but if you look at what's coming off the screen and what your eyes are seeing, which is the most important thing, that is rated in nits. If we pull down to high dynamic range, that's the most significant difference. The bottom end, or the black, is still down there at under 0 nits, but the white or the bright side of the picture has now in the specification the capability to go to 10,000 nits. So content's being mastered that way. The metadata and the headers, the information going through the distribution systems spell out high dynamic range and wide color gamut. Now, you're probably sitting there thinking, well, I haven't seen a 10,000 nit display. You're correct about that. But we are exceeding 1,000 nits, up to around 1,500 nits in the latest and greatest LCD technologies with LED backlights. And we're seeing about 600 to 700 nits with your OLEDs. So there's basically 2 specs for reproduction, one for OLED, one for LCD at this time because of the differences in technology and light output. OLED being better with the blacks and LCD being able to produce more light output. But if you haven't seen it, you need to see it side by side with an SDR display, and you will be stunned and amazed, like customers out there everywhere that are buying TVs right now. HDR is kind of a must in my mind, and we must figure out a way to distribute it through especially high-end multi-dwelling homes. So number 2 on the scale of importance is this idea of more color. And more color, there's a specification that came along when HDR came along, and it's called BT 2020. BT 2020 is the goal that we want to try to reach. Right now, we're at about 90% of P3 and about 70% of 2020. This chart, if you have not seen it before, is called the chromaticity chart. It's designed a long time ago. It's so you can ensure color matching around the globe for, you know, reproduction of movies and videos. There's other sets of things like this for fabric and art and print, but for video and reproduction of video on projectors and TVs, this is it. This is about 380 to 720 nanometers, and that is essentially human vision. So like our hearing is 20 to 20,000 or 20 to 20 kHz. This is 380 to 720 nanometers. So this is human vision out at the edges. This is how we've been watching TVs forever, this dotted triangle. It says Rec 709. So it says HDMI 1.4, but there's a lot of HDMI 2.0 that also, you know, is still mastered in 709. But now that's changing. So now we're starting to master in 2020, and for sure in D-Cinema, Digital Cinema Initiative P3, we're doing you know, the full 4K. So here's your D-Cinema. But here's 2020, and we're going to see this in the home within the next 2 to 3 years. It's going to take inventions. It's going to take a lot of scientific research. It's where you've probably heard some things like quantum dot technology, laser technology. So technologies are being developed to increase the amount of the color gamut we can use, thus getting closer to being able to reproduce items in nature that we've never seen before on televisions. That is the beauty of BT 2020 and wide color gamut. The other thing that we've gone to now is we've gone up in bit depth. So everything to this day, like a like a Blu-ray player, that's been 1080p, 24. 420 or 444, but mostly 420 and 8-bit. 8-bit gives you 1 to 255 choices, so that's your bit depth. An 8-bit system is 255 steps of gray or red, green, blue, cyan, yellow, magenta. In a 10-bit system, that number goes up to 1024. And in a 12-bit, it goes up to 4096. So by going up to 4096, we basically eliminate banding. In pictures, this is extremely important. And if you remember the previous slide, we said the normal output of a UHD player is 12-bit, and that's the same with streamers and the like. The place where this has more impact even than on film-based or digital material is gaming, CGI, computer graphics. The gamers, those are, you know, built at the pixel level. So having a 12-bit system really is impressive when you are doing gaming on your device, and it's becoming more and more popular, and not just with kids. Even, you know, young adults are gaming, doing things in tournaments. There was an article in the New York Times I saw over the weekend that was talking about how much that's increasing for online gaming and just gaming in general. So higher bit depth means more choices, means better color, less banding, more what I call RGB triplets. RGB triplet being, just for an example, in an 8-bit system, it takes 255, 255, 255 to get white, and 000 to get black. So if you kind of think about that over the entire 8, 10, or 12-bit system, you see that the amount of options for reproduction of color get way better by moving to a higher bit depth. And then the final thing, and I know this slide is a bit exaggerated on the left. It's a for effect. Obviously, that's not a 1080p signal, but it just basically shows the difference in what you get, and especially in a bigger display. The bigger display, the more pixels you need, so you don't see blocking and you know, pixel structure and other artifacts with lower resolutions. Okay, so this just is a reminder slide, and all it says is high dynamic range is more important than resolution, and we've known that based on what we see happening in the world today. High dynamic range is on the top of mind for all those ones I showed on the second page. A lot of sitcoms and TV shows on the streamers are now being done in high dynamic range, and most movies, if not all movies that are coming out today, are coming out in high dynamic range. Your customer is going to want it. They're going to see it in the store because the demos in the store are fairly impressive. They're canned, but you know, when they get it home, if it's still in SDR, they're not going to be happy. All right, so it's great, but how do we work with it? What we need is components in the system that can handle deep color, handle the extended bandwidth, handle distance. Obviously, that's where we come in. This problem doesn't really occur in 98% of the population. Unfortunately, we're in the 2% at the high end of the market in custom. In the 98th percentile, going down to Walmart and buying an HDR TV and plugging it in with a 3-foot cable, it works. So also the smart EDID in some of these is smart enough that it works, but it may be in a lower resolution depending on how they've got it set up and the cables they're using. But the components need to pass deep color, high bandwidth, distance, obviously HDCP 2.2, that's your copy protection, and then you need to have some pretty robust EDID management. We're going to talk a little bit about that in the next couple slides. So EDID is extended display identification data. It's a one-way communication from a sync device. In the world of HDMI, we have sinks, sources, and repeaters. Sink's a TV or a projector. The source is a Blu-ray player, a computer, a streamer, and a repeater does both. And it could do both at the same time or both at varying times. But that's like an AVR, a matrix switch, splitter, something like that. So you got to remember that the display sends the EDID to the source, and the source can only read the EDID. So everything should be hunky-dory. Unfortunately, we all know that about 80 to 90% of the problems in the world of distributing HDMI are EDID related. So it doesn't always work that way. What happens in our world, and you can see from the diagram below, there's always a repeater. And when you put a repeater in the system, this is where the issues start to crop up. So here's how it's supposed to work. Display is saying, hey, I'm a Sony TV. I prefer you send me 1080p, but I can handle 4K. I can't handle HDR. I'm not very good with PC formats. I was not designed for them. The source basically doesn't say hello, but they react to that information from the display, and they attempt to promise to send something that the TV can handle. All right, so that all sounds great, but what's the issue? The issue, the EDID can only be read from the next device in the chain. And the next device in the chain is not always the TV. When it is, that's i.e. the 98th percentile consumer model, 9 times out of 10 everything works. In our model, it's not 9 times out of 10 it works. It's basically, we hope it works. We hope the repeater's doing the same thing. We hope the repeater is just passing the EDID through intact. However, this doesn't happen because repeaters, like EVRs, do this differently. They can even pass information that they think may enhance the signal, i.e. scale the signal. So the repeater's doing different things. And so ultimately, there's a breakdown in communication. And sometimes there's more than one repeater. In a more complex system with more display locations, more endpoints. So this is where it breaks down. When these do not communicate directly, when a repeater gets involved, then we need EDID management to either force an EDID into some settings that the display can reproduce, or it needs to be built into the repeater product, or we need some kind of a device to fix that. And I'm sure a lot of you have run into this and know what I'm talking about. We're going to talk about how to fix it here in the next couple slides. Most installations over the last 5 years are not equipped to handle HDR. Most professional audio video equipment maxes out at about 10 gigabits per second throughput, max bandwidth. That would be your your HDBaseT stuff, 10.2. HDR is being delivered now on these devices we looked at in the chart at between 11.1 and 18 gigabits per second. So that's where the crux comes in, and that's where we start seeing no video, pink video, lack of HDR, etc. And we're just scratching our heads on, why is this happening? And we kind of can get into the pluck and chuck mentality, and maybe eventually we'll find the solution, but normally we don't, and normally that process is costly and takes extra truck rolls. So that being said, anything that is going through copper, i.e. category cable, it's going to have to be compressed in some way. And compression means shrinking the data. In other words, doing something to those bits, which there's a lot of them, to compress them for transmission over copper, and then to decompress them when they get to the other end. So HDBaseT, category over category 10.2, AV over IP, or sometimes it's called HDMI over IP, compresses to go through, in most cases, a 1 gigabit switch, and in some of the stuff I saw at CEDIA this year, now they're requiring a 10 gigabit switch, but still that's well below 18 gigabits. They get decompressed to output at 4K. Normally in the HD or AV over IP, that's where you hear stuff like MPEG-2 and H.264 and H.265, HEVC, those types of methods of compression. What we've invented is a process called ICT. We've called it ICT, or invisible compression technology, based on our many years supporting and working with the Imaging Science Foundation. We're only compressing the colors, and it's really important to understand that, because compressing the colors is the best thing when your audience is a human being, because it relates right back to the physics of how our eyes work. So ICT compression does color compression. So we take that 444, 422 signal and we compress it to 420 8-bit. We can do that because the human eye has 120 million rods and about 10 to 12 million cones. So it's about 10 to 1. So we can actually do that compression of the colors, and you really never know that anything was missing. And then at the other end, we take and decompress that back, and we get literally a lossless output on the receiver. And this is over copper. And we've shown this. We showed it at CEDIA this year. We have it at many of our Catalyst members' facilities now, and that's growing. But it's a side-by-side demo with fiber and our ICT technology over copper, and we have not found one person who has picked correctly that there's any difference between the two. So we're getting equal performance to uncompressed fiber over copper. So this is, a beautiful thing for the residential AV market, who's dealing with retrofits and systems where they just, there's not enough in the budget to move to fiber. All right, so let's get in a little bit to what we have out there and how this works. So here's 3 ways of extending full bandwidth. One, you can use fiber, right? Fiber optic is out there. There's a couple of flavors of it. There's long AOC HDMI cables. That is an active optical cable. We carry them. They look like a regular HDMI cable, really slick looking. They're pre-terminated with HDMI connectors on the ends, no power requirement. We have them in 40 to 15 meter lengths, and they do the full 4K 60 444, full 18 gig. There's fiber extenders that actually convert HDMI to optical or light and then back to HDMI. And those ones are like a traditional HDBaseT extender. They include things like RS-232 and IR, so you can deal with the control system. And those work with this field terminatable fiber, which you're probably starting to see that. Clearline is a really favorite of ours that has field terminatable fiber with a special patented polymer that it makes it easy and safe to terminate in the field even faster than you can do category cable. And then this new compression technology, ours is ICT. Most of our competitors are working towards DSC, which is the silicon image flavor. We did abandon that about 6 months ago because we just, it wasn't working, and most of it related back to the firmware on the actual DSC chip. So we did use the Panasonic chip, and we built an FPGA to work around issues that are apparent in that chip. And so we have products on the market that are shipping and supporting these formats. But that's how it works. 4K source into an ICT transmitter, over CAT, received by an ICT transmitter, converted back to 18 gig or 14 gig or 11 gig, and output to the television with the full payload, including HDR. We have connectivity products to support this in matrix switches, HDMI extenders, distribution amps, scalers, and audio down mixers and EDID minders. Starting with uncompressed HDR, we got 3 versions. They're pretty straightforward. You need AOC cable, a fiber optic cable, with Clearline with Ineos or Clearline with our transmitter and receiver, or short HDMI cables under 10 meters, or you can use the 444 extenders in here with these. So, and you can mix and match. These scalers also have, switchers also have built-in scaling, so you can scale the output. They have built-in EDID management on every port, so you can manipulate every port's EDID. They also have built-in test patterns, so you can actually test basic sync source repeater functionality with actual 4K and 2K test patterns. IR, RS-232 controllable, IP controllable, really nice user interface via IP. All the drivers that you're familiar with are available, Control4, RTI, Crestron, and the like. The other thing that you'll like about these matrices is the audio matrix is separate. It could completely be controlled separately. A lot of these on the market are follow the input or follow the output. You could do that with ours too, or you can send the signal anywhere you want it in the system. So you essentially have 2 matrices in one box, and they're all in a 1RU pack. So here's your options for connecting it: AOCs, short cables under, and if you go to 15 meters on a copper cable, you're going to spend some money on it. It's going to be fatter. I know ours is fat, flat, and it's almost comparable in pricing to the AOC. AOCs are a little bit more, but they're pretty reasonable for what they do. One of the things that I wanted to point out about all of our cables, they all have serial number on each end, even the short ones. They have a serial number, so when you go back in 3 years and you have to figure out what's connected to what, you don't have to pin them out, or you don't have to worry about it. I mean, because all the serial numbers are on both ends, and it's really easy to put them together. And then you could use our 444 extenders, and these are just some of the accessories that are available: a rack mount, and with good airflow, and tie down places for tie downs, and then a squid power supply, so you can connect up to 8 transmitters or receivers with one. I think it's about a 4 amp or 5 amp brick. All right. On to matrix switches that output directly 444 through HDBaseT ports. If you look here, we have on each output, and this is a 4x4 model, HDBaseT and HDMI. Those are, when used in conjunction with one of the 444 receivers, you can do the full 18 gig. You can also scale it. You can do normal, under 10.2 4K, or you can do 1080p, whatever you need to do. So you got a built-in scaler, up and down, built-in HDBaseT, and then special receivers that can take that signal and convert it back to 444 on the output to the TV. So nice package. Same features as the previous ones. Same thing with the audio matrix. It's also 48 volt power, so this is a PoE provider. So these ones down here do not need to be powered. The extenders come in 40, 70, and 100 meter versions. The 40s and the 70s have been shipping for about 2 months. They've been in back order a few times. They're quite popular. The 70 adds Ethernet. The 100 adds Ethernet and USB, and will be shipping in about 4 weeks, the 100 meter version. But these are a true 40 meter 4K 60 444. So you would see these sometimes marked as 70 meters for HD or 1080p or HD. Same thing with these. They'll go longer with HD. These are the specifications for 4K 60. So no confusion. These devices also have built-in EDID, so built-in EDID management in the extenders, and not only built-in EDID management, but also built-in test patterns in the extenders. So when you're setting up the extenders and you want to see if 4K is passing through, you can put it into 4K mode, and it will actually send out a 4K test pattern, and you can flip that back and forth between 2K and 4K, and you can swap through about 30 different canned EDIDs, or you can actually read an EDID from the actual display in automatic mode. Here's a typical diagram of an 8x8 matrix, which that's the highest we do on an HDBaseT output matrix. You can run these into the 444 cards also, or you can do straight HDMI cables, or you could do AOC cables, however you want, or whatever your requirements are to get those signals to those rooms. The 8x8 HDBaseT matrix is in final production now, and I know we've had a couple slips on this, but it will be shipping in mid-November to week 3 in November. But it is in final and mass production. Chassis are on hand. Final SMT work is being done, and then some testing, and then these will be out. So the 2 versions of HDMI extenders, and again, these are full 4K 60 444, 40 meter, 70 meter, all shipping, all available. Another thing I can point out that I didn't mention before, also you can power either end. So you could, in a pinch, put an extra set of these in the middle and not require any power. And you could actually double the length of the extension, powering it from a transmit side and a receive side to two boxes in the middle. The other piece that we've developed, and this one has been out there for a while now, and it is in some installers, every truck, they have, you know, 1 or 2 or 3 of these, especially the guys that are already doing HDR distribution. This will take 18 gig in and will output 18 gig. So that means full signal, but you also have this capability up here where you can do some basic edge sharpening or video enhancement, but scaling, upscaling, downscaling, and you see an HDBaseT C mode. What that means is if you use that setting, that means we're going to down convert the signal to get it through an HDBaseT system, to get it under 10.2 gig. Everything is just a button press on the side, so you don't need a computer. You just press the buttons until you get the binary equivalent down here at the bottom, and then that's what your setting is. And that's the same thing also here for EDIDs. We have canned EDIDs, user EDIDs. We can bypass EDID altogether. So this product becomes a fixer box. It could be put in line, ahead of, or behind a repeater to solve a myriad of problems that are in systems out there, and it doesn't necessarily need to be used with our products, because most of our products have it built in, but with our competitors' products where you need to fix a problem. Same thing with Dolby and DTS down mixing. We recently, in the last 6 months, acquired Dolby and DTS full licenses, so we're fully licensed to develop products, and we are actively developing products in our matrices and the like. But we did want to get this product out first because this allows you to solve the problem, you know, zone by zone. So this is a true downmix system. You have to be licensed to do this, and that's why there's not a lot of licensed product on the market. But so basically up to 18 gig in and a true Dolby or DTS downmix out. Great fixer piece. Okay, so here's another example of using our fixer EDID miner. It's you know, part number is SC1-UHD or AUHD. This is with a pre-installed system. So down here is you know, matrix or DA. This is an extender, you know, a transmitter receiver. Then if you put our box in front of the first repeater or the matrix, we'll convert it to, you know, we'll do that color compression, the ICT compression, so it can pass through this 10.2 system, and then at the other end we come out and convert it back, and now we're back at 18 gig going, I'm sorry, in here, and now we're 18 gig coming out into the TV. So you don't necessarily need to replace all the components in existing infrastructure, especially, you know, high-end, high-dollar control and distribution systems put in 2 or 3 years ago. You know, when this technology didn't exist, you can use these boxes and put them in and actually force the system to work if the customer doesn't have an in budget to replace the entire system. So a good workaround solution for retrofits. Finally, I want to talk a little bit about a test kit. We have a good-sized support staff here, and they tell me, and I hear it, that most of the problems they run into, again, are EDID related or some mismatch in HDCP or you know, just format or timings or bandwidth. So we like it when our customers have a tool. We make a tool. That's how we got started in business, making the Meridio 6A and 6G that's used by most of the big manufacturers in the world. There's a laundry list of names that you would all be familiar with who are actively using these every day. Best Buy has 6A and 6G on almost every truck now. So there is a need for a tool when you're dealing with these complex systems to troubleshoot through the system from point to point. The Fox and Hound provides reference test patterns at up to 18 gig with HDR, with HDCP switchability, turn it on, turn it off, turn it on 2.0, 2.2 or 1.4, full set of test patterns. And then on the analyzer side, so this one goes at the head end or replaces the source, and this one goes where the TV would be. So on the analyzer side, we can actually get the video coming from the generator or from the source. We can also store a couple EDIDs in the A and B buttons. We can store a couple formats in the A and B on the generator, but we can emulate an HDCP 2.2 TV, a 1.4 TV. We can look at the audio, both 2-channel and multi-channel, up to 8 channels, and we can do a cable test. So we can test all those cables that you're planning on putting into the system. So full set of field troubleshooting tools that you may want to consider, you know, when you start dealing with these HDR distribution systems. Really makes it handy for point-to-point troubleshooting. Not so much for our products, but what I'm talking about is the high-end repeaters a lot of you guys are using are high-end AVRs, and a lot of the places we have issues are with AVRs, and TVs too. Most of the components, you've heard this for the past 5 or 10 years, you got to check for recent firmware revisions on all these components, because a lot of that is dealing with the things that actually cause problems in these distribution systems. So the Fox and Hound is a good option for integrators to have on their truck for troubleshooting. And it cuts down on the pluck and chuck, and we all know we do that. I've been in tech for too long, 30-40 years, and that's what we do. All right, in conclusion, 4K and HDR products are out there. They're not going anywhere. They've already announced the HDMI 2.1 spec. It's going to increase resolution, but in reality, it's going to have HDR built in, and having HDR built in is the key with wide color gamut. It is a beast if it's not handled properly, and AVPROCONNECT can help you. So if you want to reach out to us, reach out to your regional sales manager, call into our 800 number, and we'll give you the support and help you need. All right, at this point, we're going to open it up for some questions, if there are any.
Is the generator in the Fox and Hound comparable to the 6G?
Okay, so the generator and the Fox and Hound, they're sold as a set. They're a subset of what's on the 6G and 6A. The 6A and 6G are much more advanced, and I would recommend you go out to the meridio.com website that's shown on here, and you can see the difference. Some of the main differences, we picked a feature set for the Fox and Hound that can solve 99% of the problems in the field, i.e. cable test, high bandwidth source, HDCP, HDR, all those main things. With the 6A, 6G, that's for advanced troubleshooting, where you leave it in a system for 100 days if you want. That's where you want to, if you need to go in and look at metadata, if you need to go in and look at info frames, AVI, HDR, etc. So advanced troubleshooting. But the Fox and Hound does, like I said, 99.9% of the troubleshooting you'll need to do in the field as an integrator. And again, there's also a webinar here on that if you want to learn more. We recorded it a few weeks ago, so it's very current, and that's on the Fox and Hound. And you can get more info on it right here at www.meridio.com. We've also got several handouts with this that you'll get I think it's 5. You're going to get a chromaticity diagram. You're going to get a bandwidth chart. You're going to get this presentation in a PDF and a couple other goodies. Okay, any other questions?
Yes. What is the effect that an AVR has on HDR?
That's a good question. What effect does an AVR have on HDR? Well, very good question, and the answer is it's not a simple. It's not that simple. I mean, what we would hope would happen would be that the metadata required to turn on HDR is passed intact through the system. So again, that's where the Fox and Hound come in. Most TVs, you will know you have HDR because HDR pops up on the screen, and it says, HDR. It says HDR10 or it says Dolby Vision. But what's not apparent, and you can get this with the info button on most TV remotes, is it'll say 4K or 4K, maybe 4K with the frame rate, maybe 60, maybe 24, but usually it just says 4K, and there's nowhere in the TV that you can tell what it's actually able to, reproduce at that moment, and that goes back to that chart. There's formats under 9 gig that are 4K, and that could mean the same thing. So you don't see the chroma subsampling, you don't see the bit depth. You do see that on some high-end sources, but the only one I'm aware of now is the high-end Oppos. They'll show you native format of the disk and then output format of the device, and chroma subsampling and bit depth combined. So again, what I say is test. If you don't have Fox and Hound, use the info button or see if the TV physically puts HDR on the screen like a logo. Those are the ways to test it.
Next question. Do the HDBaseT products, the ICT ones, require shielded Cat6?
Good question. Do the ICT products require shielded Cat6? No. Shielding, or STP, you have unshielded twisted pair, shielded twisted pair, STP, UTP. So you could use either. It is HDBaseT. We are members, contributing members to HDBaseT.org. So the minimum requirement is Cat5e. We recommend Cat6a. Or, I don't think anybody's doing Cat7 yet, but Cat7 works too. Shielding is an environmental requirement. If you are not sure, especially in light commercial, if there's EMI or ESI, emanating throughout a space, attic, crawl space, then it's best to use shielding. Sometimes in bars, sports bars and the like, I've seen issues where shielding was important, when there was a lot of neon signs. So shielding is more environmental. The minimum spec to get the 4K at the distances we quoted is a Cat5e. But again, Cat6a is better, and there is not a lot of difference in price parity between the two, especially when the customer's paying for it. They're probably going to want the peace of mind of 6A, or right now what we're actually recommending people do, since if you have new construction, pull 4 to 6 fibers, field terminatable type. You don't need to buy the endpoints unless you're going to terminate and use it, but that'll last you a long time, and then 2 cats, and that mostly covers you.
Anything else happening with HDR standards from source gear? We see quite a bit of variability in the source devices.
Any difference in standard on source devices? Well, the source device manufacturers, there's a consortium that's involved with Dolby Vision that includes some of the big boys, and there's everybody else, and everybody combined uses HDR10, which is the SMPTE version. Dolby Vision is licensed version. HDR10 is unlicensed versions, but it really comes down to the content masters, right? What are the actual content producers going to, do and put on the disc? Is it going to be encoded as Dolby Vision? or is it going to be encoded as HDR10? And now Samsung has come out with HDR10 Plus, which is their emulated Dolby Vision. Difference between the two is Dolby Vision is scene by scene, and it can be down to every frame of the movie. And HDR10 Plus tries to replicate that, and then HDR10 is the treatment is applied to the entire movie, a max luminance and a min luminance. So I guess to answer your question, the UHD or Blu-ray player manufacturer or the source manufacturer should just stick with the standards. I know maybe this question is relating to the Apple TV that just came out, the 4K. You know, if you look at the format page on that, I got one home the first day it landed, and it's got 1080p HDR. So, you know, they're injecting more confusion into an already muddied market. You know, 4K or high dynamic range is coming with UHD as the accepted method, but like I said, the HDR is not by specification tied to a resolution. So you can do that and apply that to 1080p material. But I think for the purpose of what we're talking about in this presentation, which is the high-end clientele, the high-end clientele is moving away from 1080p to full 4K, and for sure with high dynamic range and wide color gamut. That's it. Okay, I don't have any other questions, and I appreciate your you know, paying attention for the last 52 minutes. Like I said, if you need more information, there's some websites listed on here. If you'd like to get involved in more training in the field, where we go out and do 2 or 3 days with the THX guys and the ISF guys, that's all out at this site right here. Check back often. We'll be posting the 2018 complete schedule here in the next week or so. All right, thank you very much and have a great day.